For this example, with the given right triangle below, we want to find sine, cosine, and tangent in terms of the angle A. And the thing about trig functions is that we end up describing a lot of the same things just from different contexts. So it's very, very important that we identify here that we're talking specifically about what happens at A. If we talked about B, we'd end up with a lot of the same things, just reorganized a little bit because we'd be talking about different connections. We're talking about things from, well, a different frame of reference, a different angle, if you will. So just be very careful about these things because it's very natural when dealing with trig functions to end up getting values that look very different, but that still ultimately describe the same locations, the same ratios, the same connections, because it's all a matter of how we choose to frame these problems. There's never only one way to think about things in terms of trig, even though we're going to keep things fairly myopic here for the sake of simplicity. Anyway, the first thing you have to do with this triangle is understand that we're given the two leg lengths. We need the hypotenuse. I'm not going to write it up here because we had practiced with that before, but so that we know, if we want to get that last side length, we would have 12 squared plus 5 squared is 169, 144 plus 25. Take the square root of that, and you get that the hypotenuse has length 13. So, with hypotenuse having length 13, we can get sine, cosine, and tangent specifically in terms of A. Remember, we are thinking with A, not B, and certainly not C, because C is the right angle, and that would be really weird. So, for A, we're looking at the side opposite of A, where the side opposite there has length 5, and the hypotenuse has length 13, so sine of A is 5 over 13. For cosine, we're looking at adjacent over hypotenuse. The length adjacent to A the side adjacent to A, has length 12, so cosine of A will be 12 over 13, and then tangent, where we are looking at the side opposite over the side adjacent, will give us 5 over 12. Again, context is everything here, and how we choose our locations is vitally important as well, where oftentimes we're going to be dealing with these things in terms of, let's say, not so certain parts, and we're just going to have to think about what the relationship we have defined has to be given what we have. In this case, we don't know what A and B are, but it doesn't matter what A and B are. We know the side lengths, so we can still talk about what cosine wants to do in terms of those side lengths. We can still talk about what sine wants to do in terms of those side lengths. We even talk about the other three trig functions, but well, we probably won't. So let's get one more example here, looking at it from a slightly different perspective, a slightly different angle, if you insist. So for this, we want to find the length of the hypotenuse for a right triangle with side length 10 adjacent to an angle with measure 60 degrees. So the most important thing to pay attention to here is that we're given one side length, 10, and that we are talking about something adjacent to that side length. So what we have here is cosine of 60 degrees is equal to the ratio adjacent over hypotenuse. And I'll call hypotenuse here C because that's the standard notation we have in this class, where knowing what cosine of 60 degrees is a matter of knowing something like the unit circle, which is probably a bit outside the scope of this class, or if we're careful, knowing what we can do in the calculator to get our value here, that cosine of 60 degrees is going to be a value of 1/2. So we have 1/2 is equal to 10 over C, and hopefully at this point we can guess what C should be in terms of common ratios, but just to be sure, we can cross multiply and divide here to get that this tells us C has to be 20. And necessarily when dealing with trig functions, we are going to be doing more stuff with calculators because even for the convenient angles, it's not always obvious until you get a lot of practice with these things that something like cosine of 60 is going to be 1/2 based on things like a 30, 60, 90 right triangle and a whole bunch of intuition that has to build over time. So, unlike most everything else here, there's a little bit that can't be avoided in terms of needing, at the very least, a scientific calculator that can handle sine, cosine, and tangents. I'm going to try to be careful to stick to ones that are more or less tame in the way that this is, but sometimes, especially for real-world applications, it's a little bit unavoidable. And that is what we're going to be looking at next.